All right, so sections 12.2 and 12.4 we're going to group together because they talk about arithmetic sequences and series. Don't worry about 12.3, we'll get to that later. Arithmetic sequence, that is a sequence in which the difference between successive terms is constant. So what we're going to do at these two examples here is we're going to figure out which one is arithmetic and which one is not. So first thing you're going to do when you look at this, to move from 2 to 5, you're adding 3. And then from 5 to 8, you're also adding 3. And then from 8 to 11, you're adding 3. So that means that each time to get to the next term, you're always adding the common number. In this case, it was 3. So that would be the common difference. Okay, so the difference between successive terms is constant. So this one, yes, we'll put a big check mark here. Yes. Okay, so that one is arithmetic. So if we look over here, why is this one not arithmetic? Well, to get from 1 to 2, you're going to add 1. But then to get from 2 to 4, you're adding 2. And then from 4 to 7, you have to add 3. And then you have to add 4 and then add 5. And you can imagine each time you're adding 1 extra onto it. So this one is not arithmetic. Okay. So I had mentioned this common difference thing. And I need to erase. Gone. Okay, oops, got a little bit there. So the common difference is that number that you either add or subtract. It's the same each time you're adding or subtracting to get to the next term. So the way we define this, D is equal to A sub n minus A sub n minus 1. So what does this mean? Well, remember that A sub n is just a generic term, right, in your sequence. Well, n minus 1, that means it's the term before it. So if you take one term and subtract the term before it, you get the same thing every single time. It's called a common difference. So let's test that out. Here, 11 minus 8 is 3. 8 minus 5 is 3. 5 minus 2 is 3. So 3 would be the common difference. All right, so we're going to go through and do this little exploratory thing here. So based off of our common difference formula here, A sub 2 would be equal to A sub 1 plus D. So you take this term, add your common difference, and you should get the next term, right? Okay, so A sub 3, it would stand to say that you would take the second term, add your common difference. Well, right now, if we replace A sub 2 with what we got over here, which is A sub 1 plus D, we plug that in right here, but then we also had that D on the end, we now get A sub 1 plus 2D. Okay, let's try it again. A sub 4, well, that's going to be the third term plus your common difference. When we just evaluated A sub 3 is equal to A sub 1 plus 2D. So there that is, but we had to add on our extra D, so we get A sub 1 plus 3D. So hopefully with these three terms here, you can kind of see a pattern. And what we're going to do is we're going to come up with a way to figure out A sub n, any specific term, in terms of A sub 1 and D. So if you look at this, all three of these terms started with A sub 1, and then you're adding something. In this one, you would adding D. This one you added 2D, this one you added 3D. So you can imagine the next term, A sub 4, you would be adding 4D. Or I'm sorry, that was A sub 5. You'd be adding 4D. A sub 6, you'd be adding 5D. So maybe we can come up with a rule or a formula to figure out the nth term of an arithmetic sequence or series. And that would be to take the first term, A sub 1, and add n minus 1 times D. So if you wanted A sub 5, you're going to take A sub 1 plus 5 minus 1, which is 4, times whatever the common difference happens to be. So let's put this to work. Let's test this out and see how it goes. So for the arithmetic sequence where A sub 1 is equal to negative 6, your common difference is 2/3. Find A sub 10. So they're asking us to find the 10th term of our sequence. Okay, so A sub 10, plugging this into the formula, you would take the first term, A sub 1, which is negative 6. You add the n minus 1, so n is 10. N is right here. 10 minus 1 times the common difference, which is 2/3. And now you just simplify this all out, and you end up getting a sub 10 is 0. So the 10th term would be 0. Okay, here's another type of problem that you're going to encounter. They're going to give you two specific terms. Maybe it's the 3rd and 8th term like in this example. Maybe it's the 5th and 20th term. Who knows? They're going to give you these two specific terms, and then they're going to ask you to find the first term, the common difference, and perhaps the first 4 terms of the arithmetic sequence, but definitely the first and the common difference. So what are we going to do here? Well, let's think about this. If a sub 3 is equal to 5, I can use my formula and say that 5 is equal to the first term plus n. Remember, n is right there. That's 3. 3 minus 1 times the common difference. Well, this equation has two variables, a sub 1 and d. So if I wanted to solve for a sub 1 or to solve for d, I'm going to need a second equation. So that second equation is going to come from the second term here, that is a sub 8. It's actually not the second, it's the 8th term, right? But it's the other term that they've given us. So a sub 8 is 20. So I'm going to do the same thing and say 20 is equal to a sub 1 plus n minus 1, which is 8 minus 1, times d. So now I have a system. And you know that with systems of equations, we can either use substitution or elimination method, probably not graphing method, in order to solve. So let's simplify these. So I get 5 equals a sub 1 plus 2d, and then 20 equals a sub 1 plus 7d. I personally am going to go for the elimination method. I'm going to subtract these two equations to eliminate a sub 1, and I get negative 15 is equal to negative 5d. And that means that d is equal to 3. So I found this part. So how do you think I could find that part? Well, very easily I can plug this in to either one of these equations and solve for a sub 1. Okay, so I get a sub 1 is negative 1. Now, knowing a sub 1 is negative 1 and the common difference is 3, I can easily write any number of terms I want in my sequence. So I'm going to start off with negative 1, add 3 to get 2, add 3 to get 5, add 3 to get 8. Okay, and you could have gone as far as you wanted to go, but that's it. Pretty nice. Okay, so arithmetic means, what are those? Well, all that is terms between any two given terms of an arithmetic sequence. So remember, your sequences technically go on forever and ever. They're infinite, right? And so if you just look at a certain portion of your sequence, and you look at the first and last term of that portion, any of the terms that are in between are considered arithmetic means. So if I have this sequence 2, 4, 6, 8, 10, and I look at 2 and 10 as being the first and last, the 4, 6, and 8, those terms that are in between, those are the arithmetic means between 2 and 10. But what if I had said, what are the arithmetic means between 4 and 8? Well, there's only one term in between 4 and 8, and that's 6. So arithmetic means, there can be as many or as few arithmetic means as you want in an arithmetic sequence. It all just depends on what the first and last terms are that you're looking at. Okay, so what are we going to do with that? They're gonna ask us to find specific arithmetic means between two numbers in an arithmetic sequence. So for example, here I want two arithmetic means between 4 and 79. So what we're going to do is we're going to say 4 is the first term and 79 is the last term in this little partial chunk of the sequence. And we want two arithmetic means. So I'm going to leave two spaces blank in here for us to figure out. So using our formula, we know that this is the fourth term, this is the first term. So I can say that 79, the fourth term, is equal to the first term plus n, which is 4, since this was the fourth term, 4 minus 1 times the common difference. And now all I have to do is solve for d. I get d is 25. So once I know d is 25, that's your common difference. You just add it, right? So take 4 and add 25, and we get 29. To get the next term, we're going to take 29 and add 25, get 54. And just to double check, make sure that you did do everything, all your calculations correct, add 54 plus 25 and make sure that you're getting 79. Because, you know, every once in a while you make a little careless error or something, which you wouldn't necessarily know until you see at the end if it worked or not. Okay, so that's arithmetic means. All right, so now we're going to shift into the arithmetic series. So there's actually two formulas to figure out the sum of arithmetic series. The first formula is where you take the partial sum to whatever number of terms is going to equal to that number of terms divided by 2, and then you're going to multiply it by the sum of the first and the last terms. So you add the first and last terms, whatever that is, multiply by n over 2. And that's a great, easy, simple formula as long as you know what the first and last terms are. Sometimes you don't know what the first and last terms are. So what you could do is if we took this formula and plugged in our formula for a sub n and simplified it down, you end up getting this formula. So there's still the n over 2. 2a sub 1 plus n minus 1 times d. Well, this n minus 1 times d, that should look familiar from our a sub n formula. All we're missing is a sub 1, right? Well, we add it to the original a sub 1. That's how we got 2a sub 1. Should seem very obvious, hopefully. I would say don't be reliant on just one of these formulas because there's definitely times to use one over the other. So definitely get both of those locked in your brain there. Okay, so let's practice using them. It says find the sum of the terms 7 plus 12 plus 17 plus ... all the way out to 10 terms. So they want the partial sum for 10 terms of this arithmetic series. And I know it didn't say it was arithmetic, but we can test it. If they don't tell you, test it, right? So it looks like we're adding 5 each time, which is good to know because we're going to need that to plug it into our formula. So we're going to do s sub 10 is equal to 10 over 2. Multiply it by 2 times a sub 1, which was 7, plus n minus 1, so 10 minus 1, times our common difference. Now you just work all this out, and you get s sub 10 is 295. All right, what if they give it to you in sigma form? Okay, well this is probably where we would want to use that formula. So it's really easy to figure out what your first and last terms are when you're in sigma form because you just plug in this number down here for k, that gets you your first term. Plug in this number for k, that gets you your last term. And then you just have to figure out how many terms are in your series. And it's really easy if k starts off at 1, you just look at that number. But if k starts off as anything other than 1, you're going to have to take a moment to think about it. Okay? So a sub 1 is going to be 6, and a sub 5 is going to be negative 2, and there's 5 terms in our series. So we're going to do 5 over 2 times 6 plus a negative 2, and that works out to be 10. All right, so that's how you would use either one of these two formulas, and we just have one last thing to work through, and that is a word problem, because I know how much you love word problems. They're actually not that bad. So if you look at this one, it says Mary saved 1 quarter on January 1st, 2 quarters on January 2nd, 3 quarters on January 3rd, and so on and so forth until January 31st. How much money did Mary have or save by the end of the month? Okay, well, I'm going to kind of have to figure out which of our formulas you would want to use because it's definitely a sum. We're adding these quarters all the time, right? So we want the total amount of money at the end of the month. So if we think about it, there's 31 days in the month of January, so that's how many terms there are, 31 over 2. And we know on the first month there's 1 quarter, on the first day of the month is 1 quarter, and the last day of the month there's 31 quarters. So you just have to add these together, multiply by 31 over 2, and we get 496. So there's 496 quarters, but it asks how much money did Mary save by the end of the month. So since, 25 cents is a quarter, it comes out to be $124. So that'd be nice to have $124 at the end of the month. Just to do as you please, right? Okay, well, there you go. That's arithmetic sequences and series. Later.